Welcome to Maths with Paru. Today I shall be discussing a question from P2 January 2021 paper. It's based on differentiation and using the differentiation laws. Now the question begins with y is equal to x cubed minus x squared minus 16x plus 2. Using calculus, find the x coordinates of the stationary points of the curve. Now we all know that to find the stationary points, we have to find dy by dx, equate it to 0, and then solve the equation for x. So when we differentiate x cubed, we get 3x squared. When we differentiate x squared, we get minus 16x. When we differentiate minus 16x, we get minus 16, and we equate it to 0. Then we go ahead and factorize this to end up with 3x minus 8 into x plus 2. When we solve it for 0, we get x is equal to minus 2 and x is equal to 8 over 3. Now that is then the first, they're asking for the x coordinates, the stationary points. So that will give us the answer for the x coordinate of the stationary points, which is x is equal to minus 2 and x is equal to 8 over 3. Now we're going to answer the second part of the question, which is justify by further calculus the nature of the stationary points. Now what they mean by that is we have to establish whether the points are a maximum or minimum. Now the theory to do that is that we have to find the second differentiation, d2y by dx squared. So here we already have dy by dx, which is 3x squared plus 2x minus 16. When I differentiate 3x squared, I get 6x. When I differentiate minus 2x, I get minus 2. So d2y by dx squared, which is the second difference, is 6x minus 2. Now what I do is I go ahead and I substitute these values of x equals minus 2 and x equals 8 over 3 into d2y by dx squared. So when x is minus 2, d2y by dx squared is minus 14, which is less than 0. Now from the theory, we know that if d2y by dx squared is less than 0, it is a maximum value at that point, minus 2. The other substitution would be when x is equal to 8 over 3. So when x is equal to 8 over 3, we find that the second differentiation, 6x minus 2, is going to be 14, which is positive. Now we know that when the second differentiation is positive, it is a minimum. Hence, we are able to establish that at x equals minus 2, we get a maximum, and at x is equal to 8 over 3, we get a minimum. That answers question 2. I hope you understood my explanation. If you need any clarification, please send me a message. That's all for now. Until my next video, goodbye.